Hello everyone, welcome to this video lecture online. Today we start independence. So today our article is about independence. So it is 1.6, independence. Okay, first of all you define independence. So independence of two independent events. So for example, if you have event A and event B are independent, if and only if I calculate the probability of AB, that is equal to product of their individual probability, that is probability of A times probability of B. So if this property holds, then we say that event A, B are independent. So if we use this definition for independence, so we can say that from independence of two events, we further say that this implies that if we take a conditional probability of A given B as events A or B independent, so this means that this probability is equal to probability of A. Because there is no independence, so conditional probability doesn't matter. Similarly, probability of B given A is equal to probability of B. So this is first thing that we extract from independence. So, but important thing to note here is that important point you have to note that independent and disjoint are not same. So means that it doesn't mean that if a set is disjoint, it is also an independent. So there can be some exceptionals. Okay, in few cases they do have similar meaning, but normally this is not the case. So disjoint events have as disjoint events have no outcome in common, and therefore probability in that case for AB is equal to 0. So exceptional only occur at disjoint events normally probability of AB is equal to 0. So they are only exceptional consider that they are also independent. It is only possible when probability of A is 0 or probability of B is 0. So this is we have to be careful when we are discussing disjoint and independence. So independence is not the same definition as disjoint. So for example, if let's clear this thing using an example here is 1.21. Now this example says that suppose that for the 3 lights, each outcome is a sequence of 3 lights, each either red or green. So what we have a sample space for 3 lights that can have either green or red. So either all lights are red, 2 red, last green, first red, middle green, first green, last 2 red, or 1 red, 2 greens, or green, red, green, or you can have green, green, red, or you do have 3 greens. So this is the sample space of your experiment where you have 3 lights. So each light has 2 colors, so there are 8 outcomes. Now this is my sample space of the problem. Now question is that when we say R2, it says that R the capital R2 that the second light was red. Okay, so R2 means that if second light is red is an event. So and G2 that the second light was green. Now these 2 events. Now question is question is that are the following events are independent. So first they want to know about R2 and G2, then they want to know about R1 and R2. So this is a question we have to solve for these events. Now how we do that? First of all, it's better to write here, if I go to the next page, so it's better to write R1. So what outcomes come into R1? So R1 means that first your light is red, so it becomes, these are the outcomes that come under R1. Okay, so there are 4 outcomes that satisfies R1. Similarly, if I wrote R2, in R2 case we have second is red, so we are just writing all these outcomes using a sample space. Now similarly, if I wrote G2, after that it's very easy to calculate the independence. For G2 is OR G OR, similarly OR G G, and G G R, and triple G. So as we know that all these outcomes are equally likely, so the question is, what is the probability of, well, let's write the probability of R1, because all these outcomes are equally likely. So in that case, each outcome is 1 by 8, so there are 4 outcomes in R1, so it becomes 4 by 8, that is 1 by 2. Similarly, in second one, probability of R2, there are 4 outcomes and each outcome is equally likely, it also becomes 1 by 2. Similarly, for G2 case, I also have 4 by 8, 1 by 2. Now first question is to find the independence of R2 and G2. Okay. Question is, are R2 and G2 independent? This is first question we need to answer. How we do that? We take the probability of R2 G2 and then we have to prove that this must be equal to R2 times probability of G2 for independence. Now in this case, probability of R2 G2, so if I calculate the probability of R2 G2, I have to look out those outcomes that are common for R2 G2. In that case, there is no outcomes common because R2 represents the second light, G2 also represents the second light. So in that case, this is equal to 0. Now look at the probability of R2 as we already calculated is 1 by 2. Similarly, probability of G2 is also 1 by 2. Now, this implies that R2 G2 not equal to probability of R2 times probability of G2. But one thing you can see here, but G2 and R2 are disjoint. So this example shows us that it is not necessary that you have disjoint is also independent. So this example clearly states that. Now let's do the next example here. The next one is R1 and R2 are independent. So this is the next question. So we have to calculate probability of R1, R2. So in that case, when we do that, it becomes 2 by 8. Okay, that is equal to 1 by 4. Now we already calculate probability of R1, that is equal to 1 by 2. Okay, so it's 4 by 8. It's better to write this. Similarly, probability of R2 is again 4 by 8. So apply the formula. So in that case, probability of PR1 R2 must be equal to 4 by 8 times 4 by 8, that is equal to 64. If I enter it as simplification instead of writing it again. Okay, this is when I multiply it. So if I do a simplification here, so it becomes 8 or 1. So it becomes 1 by 4. Now so hence this implies the probability of R1 R2 is equal to probability of R1 times probability of R2. This implies that R1, R2 are independent events, and this is true because R1 represents the first light, R2 represents the second light, so it is independent. So important thing is that but R1 and R2 are not disjoint events. Why? Because R1, R2 is not equal to 0. So look here, they are independent but they are not disjoint events. Now let's move forward. Let's consider another definition. So before we discuss the independence of two events, what about if they are more than two? So there is a definition. 1.8 says 3 independent events. So now we have 3 independent events. Now for example, event A1, A2 and A3 are independent if and only if. So what are the conditions? There are 3 conditions. First one, A1 and A2 are independent. This is the first condition. Second, A2 and A3 are independent. Third condition is that A1 and A3 are dependent. And last condition, which is important, which is actually the main condition of independence, is that if I take the intersection of A1, A2 intersection A3 must be equal to, their probability must be equal to product of individual events probability, that is probability of A1 times probability of A2 times probability of A3. So this is the definition when we extend up to 3 events. Now for example, if we look at a quick example here. Now in an experiment with equally probable outcomes, the event space given to us is 1, 2, 3 and 4. So now question is that as we know that this is equally likely, so probability of individual outcome is 1 by 4. Now for all small s belongs to your universal set, or question is, are events, so A1, that is 1, 3, 4, A2, that is 2, 3, 4, and A3, that is equal to null set, are independent events. So this is the question we need to answer. So before that, so if first of all I have to check the independence of A1 and A2. So for that reason, first of all let's write the probability of A1. So probability of A1 is actually equally likely event, so it becomes, there are 3 outcomes, so it becomes 3 by 4. Similarly probability of A2, so there are 3 outcomes, again 3 by 4, and probability of A3, there is no outcome, so probability is 0. Now after this information, first of all I have to check the A condition that says that A1 and A2 are independent. Now for that case I have to take the probability of A1 times A2 must be equal to probability of A1 times probability of A2. Okay, so to check this, let's see the probability of A1 and A2. Now if I look at the events A1 and A2, that I better to write it here again so that you get the idea what are the outcomes. A2 is 2, 3 and 4, A3 is empty set. Now for A1 and A2, so there are two elements that are common, so it becomes 2 by 4, that is 1 by 2. Now we already calculated the probability of A1 3 by 4 and probability of A2 as again 3 by 4 and probability of A3 which is empty is 0. Okay. Now if I plug in the values here, it becomes 1 by 2 must be equal to 3 by 4 times 3 by 4, that becomes 9 by 16. So this is not equal to this, so this implies that A1 and A2 are dependent events. Hence A1, A2 and A3 are not independent events. Okay. So this is the way you just check it and you identify that are they independent or not. Okay. Now if we look at the definition, so what about if there are 4 events? So for that case we have a definition here, and that definition is 1.9 that gives us generalized independence definition, that is for more than 2 independent events. For that case we have this definition, and it says that if n is greater than or equal to 3, the set A1, A2 up to so on An are independent if and only if A part says that every set of n minus 1 sets taken from A1, A2 up to An is independent. So that means that you have to pick all the sets and look at the independence. And the second one is that the main probability, take the probability of the intersection of all these events, and they must be equal to probability of individual events product. So if these conditions hold, so this means that you can extend this to any number of events, independence definition. So let's do a quiz. .6 on independence, and quiz says that monitor 2 consecutive phone calls. Okay, classify each one as a voice call if someone is speaking, or a data call if call is carrying a modem or fax signal. Okay, Your observation is a sequence of two letters, either V and D. So this means that we have a sample space here that is both voice call, voice data call, data voice call, or both data call. So each event is equally likely, so this means that probability of S equal to 1 by 4, where for all S belongs to S. Okay. Now now this is if they are equally likely, but it says that your observation is a sequence two letter. The two calls are independent and the probability that any one of them is voice call is 0.8. Okay, so this is not the case, they are not equally likely, but instead they give some extra information to us. So what extra information they give us? They say that two calls are independent and the probability that any one of them is a voice call is this. So any one call is a voice call. For example, if I represent CI as a call, identity of ith call. Okay, so C1 means first call, C2 means second call. Okay, so I call can be equal to voice or I call can be equal to data. Okay, now if it is voice call, so in that case we have a probability given is 0.8. So count the number of voice calls in two calls you have observed. NV is the number of voice calls. So NV represent number of voice calls. Alright. Now the next thing they say consider three events. So three events. Sorry about that. There are three events. Events that is represented by NV equal to 0, NV equal to 1, and NV is equal to 2. Okay. So now question, determine whether the following pair of events are independent. Determine independence. Now this is a question. So before solving this question, it's better to write the events and with number of voice calls. Okay. For example, how many voice calls we do have? We have 0, 1, and 2. Okay. Now when it says NV equal to 0, so this event actually corresponds to only this outcomes, and when it says NV equal to 1, so this event actually corresponds to following voice call, that is VD and DV. Okay. Now so the question is that if any call is so means the probability of Vi is equal to V is given us is 0.8. Okay, so this is given to us that probability is 0.8. Similarly, if this is 0.8, so in case of data call, this is equal to 0.2. So these things given to us. Now question they are asking is, first one is we have to find that NV equal to 2 event and NV equal to 1 event are independent. So how we find that they are independent or not? So for that case, it's better to write the NV equal to 2 event in terms of outcome. So NV equal to 2 has only one outcome. Similarly, NV equal to 1 has following outcomes, that is VD and DV. Now to prove that they are independent or not, we have to take the intersection of, we have to calculate the probability of NV equal to 2 event, because there are two voice calls and individual probability is 0.8, so this means that 0.8 times 0.8, because there are two voice calls, so each is represented by 0.8. So in that case it becomes 0.64. Now similarly, probability that NV is equal to 1, so we have two events, so if we wrote the probability of both of them, that becomes as we know that probability of D is 0.8 times 0.2 plus probability of 0.2 times 0.8. Okay, so it becomes 0.16 to 0.2 times 0.16. Okay, so in that case it becomes 0.32. Now to calculate the probability of NV is equal to 2 intersection NV is equal to 1, so in this case there is nothing common between these two, so it becomes probability of empty set, that is equal to 0. So this implies that NV is equal to 2 and NV is equal to 1 are dependent event, because they didn't hold the definition of independence. So the next question, better to move to the next page. Next question is probability NV is greater than or equal to 1 and first score is V. Now again we have to write the events first so that we can understand what are the outcomes. So for NV is equal to 1, so we have VV, because it is greater than or equal to 1, so in that case VV, VD and DV. Similarly for first call is voice call, so it contains VV, VD, so these are two outcomes. So if we write the probability of NV is greater than or equal to 1, in that case, because voice call is 0.8 times 0.8 plus 0.8 times 0.2 plus 0.2 times 0.8. Okay, so in that case if I do simplification it becomes, okay, if I do simplification it becomes 0.96. Okay. So similarly if I calculate the probability that C1 is equal to V, in that case first call, so it becomes 0.8 times 0.8 plus 0.8 times 0.2, so it becomes how many it becomes? It becomes 0.8, 0.64 plus 0.16. So if I do that, it becomes 0, 1, 80. Okay. So if I calculate the probability and v is greater than 1 with the probability of C1 equal to V. In that case, look at the combined, so there's only one, sorry, two. In that case, it is probability is 0.80. Again, probability of NV is greater than 1 and C1 is equal to V is not equal to probability of NV is greater than 1 times probability of C1 equal to V. So, are dependent. Now let's move to the third one. Third one says that probability, we have to look at the event when C2 equal to V and C1 is equal to D. So let's make this event first equal to 2. So this event includes VV and DV. Okay. So similarly the next one, C1 equal to D. So in that case this event includes DD and DV. Now let's calculate the probability of C2 equal to V. So in that case probability is 0.8 times 0.8 plus 0.2 times 0.8. So it becomes 0.80. Probability of C1 equal to D. So in that case it becomes 0.2 times 0.2 plus 0.2 times 0.8. So this probability is okay, the point 0.40 plus 0.16. So 0.04. Okay, so it becomes 0.20. Now again, if I take the probability of event that C1 equal to D intersection probability of C2 equal to V, so in that case is there any outcome common between them? So there's one. So this is equal to probability of this event, that is dV, and you know that dV is 0.2 times 0.8, that is 0.16. Now if I apply the formula for independence, so this implies that probability of C1 equal to D times probability of C2 equal to V is equal to, if I do multiplication at 0.8 times 0.2, so it becomes 0.16. So these two are same, so this implies that C2 equal to V and C1 equal to D are independent events. So this is the way you can prove it. Now let's see the last one. Last question is that you have to find that C2 equal to V and NV is even. So it's better to write outcomes first of the event set C equal to V So second is V, so in that case dV and VV. Now the first one NV equal to E1, so we have E1 is 0 and 2. Okay, so now let's look at the output of these. For 0 we have DD, for 2 we have VB. So now take the intersection of these events. Let's see what are the outcomes in their intersection. Okay, now in that case intersection is VV. Now to write the probability, we have to calculate the probability of C2 equal to V intersection. Probability of NV is even. Now they must be equal to probability of NV is even. So even times probability of C2 equal to V. Now let's look at the probability here. It becomes 0.8 times 0.8, and this is equal to probability of even is again 0.2 times 0.2 plus 0.8 times 0.8. So then times it becomes 0.8 times 0.8. So this is not equal to, so this implies that even C2 equal to V and NV is even or dependent. So this is the way you can solve these independents. So I will stop here. Thank you.